We've seen for a wave that its wave speed shows how the wave is traveling, and it's different than the displacement of the material in the wave. So wave speed shows how it's traveling. Okay, and we found that it's equal to the wavelength over the period. Remember, the wavelength is the distance between any two parts that are in the same point of the motion. So valley to valley, crest to crest, or to the right of a crest to the next crest right, and so on and so forth. That's the wavelength, and the time it takes for that to pass a point is the period, such that we get the velocity is equal to the wavelength over the period, and we can rewrite that and say the wavelength is, or the velocity is equal to wavelength times the frequency, because the frequency is the inverse of the period. Okay. Now this is a very fundamental relationship we're going to see frequently pop up in all types of in all wave motion, but in sound, in light, and all sorts of different areas of study. And so it's really important to remember this one. I'd say it's one of the more important relationships in this course. But what's really interesting about it is you can actually describe or explain the different parts of it based on the natural problem, the physical nature of the problem. And so a better way of writing this is that the wavelength is equal to the velocity divided by the frequency. Now, why is that? I often like to write Newton's second law as acceleration equals force divided by mass. Okay? If you apply a force to an object with mass, it will accelerate. This is the result. Okay? This is the action. This is a property of the object, and this is the result. We have something very similar here. Okay? Something very similar here. This frequency is controlled by the source. Okay? It's a property of the source. And by source, I mean the source of the disturbance. So this might be your hand moving a string up and down. You're controlling how many times you do that every second. It doesn't depend on anything else. It's just you're doing it. If it's a sound wave, you might be tuning a speaker to oscillate at a certain frequency. So you're controlling that frequency. And so the frequency generally is a property of the source. It will only change if the source changes. So my string, the frequency of the oscillations on my string will only change if I change that oscillation. Okay, so that's property of the source. Now we can go into some more detail to find what this is dependent on, but in the end, the velocity is dependent on the material or the medium. So like on a string, the velocity on a string is purely dependent to how that string is set up. What is the tension between the molecules in the string? What is the mass of the string? Or more so, what is the mass density of the string? In water, this depends on the density of the water and the gravitational acceleration that's causing it to pull back down, to want it to lay flat. But this is always a property of the medium. Okay? The thing that results is the wavelength. Sometimes we think, oh, I see that wavelength, that's a fixed thing. But if I change my medium, the wavelength changes. If I change the source, the frequency changes, but then the wavelength will change. So the wavelength is the result. So that's why this is a better way of writing it, is the wavelength will change whenever the velocity changes, the frequency changes, but the frequency will only change if the source changes. The velocity will only change if the medium changes. So those are fixed by the outside controls. Wavelength is what connects the two.